So the concept of this circuit is that we're just supplying some voltage from this end of the conductor to this end of the conductor, right? Now, in a way, we can say that this conductor is a bit like a parallel plate, right? We can say the electric field in there is the change in voltage over the R, and I think there was a minus sign in there, something like that, right? Which is just voltage divided by distance, right? Is that concept. So we can, if we know the potential difference between here and we divide by the length of this thing, right? Whatever that voltage is divided by that length is the electric field in there. Okay. We also have the important formulas are current is related to the drift speed with N area, the drift velocity, right? Times the charge, right? Well, this is always E, which is 1.602 times 10 to the minus 19th. Coulombs. If it's a wire, I mean, I can't think of a situation where you have a conductor that doesn't have electrons, but there must be some situation where they would have just put E in there. I just can't think of one. This is the drift velocity, and that's going to be meters per second, right? Or properly meters seconds to the minus 1, right? That's the cross-sectional area of this thing, right? Right, and then this is how many free electrons per cubic meter. Well, this is a tremendous number, right? I mean, a cubic meter of, say, copper is tons and tons of copper, right? Just, and then, how many moles of copper that is, right? But this is, for, I don't know, typically they're times 10 to the 28 free electrons per cubic meter, right? Okay, well, if you figure all that out, then you can relate the current to the drift velocity, right? So for this first one, literally just use that formula, right? The N you've got right here, that's our N. A is right there. V is given to you right here. It's going to be kind of a lot. That's a pretty high drift velocity. And then you're going to put in the electron charge for the charge of the current carrier, okay? So that was just plug and chug, right? What's the resistance of the wire? Well, we're going to use the other one, which is the resistivity. Resistivity is resistance times area divided by length, right? So this area that we're talking about is that, right? That's the cross-sectional area. This is our length. And then read this little rho character, right? That we used for density, by the way. This guy is the resistivity. It's the inherent ability of the material to resist. So the higher that resistivity is, the more resistance you get, right? These guys are directly proportional. Now, I never think of it this way. I always say R is resistivity times length over area, right? At least I think I learned it that way, but this, there you go. Who knows? Okay. So what is the resistance of the conductor? Well, you've got the resistivity, you've got the length, you've got the area. So plug them in there. Yeah? All right. What is the potential supplied by the power supply? Well, you have the current, you have the resistance. Is V just IR? It is. Yeah, that's fun, right? Okay. And then show that the potential is given by NVQLP. Well, we can do that. Let's see, V is IR, right? So substitute for I, substitute NAVQ. That's from our drift velocity equation, right? And for R, substitute rho L over A. Yeah? And there it is, right? Now, on the test, you have one of these where you got to show something. Spoiler alert, what it is that you're trying to show is what E is. Show that E equals some expression, okay? Now, how are you going to do that? Well, you've done half of it, haven't you? Right? V is IR, you substitute this for, right? Okay, you're going to substitute that in there, right? And now you've got what V is. All you have to do is divide by L, and you'll have E. Yeah? Yeah? Again, so I'm going to ask you, instead of what is V, I'm going to ask you for this E. Okay? So E is going to be V over L, which is going to be IR over L, right? R is this. Plug that in. I is going to be this. Plug that in. Yeah? L, things are going to cancel. Things will cancel. It'll turn into this beautiful expression. And I do ask you to say, I'll say, well, where E is the, what electron charge or something like that. Okay. Yeah. Should be good.